Welcome back. I didn't intend for this to be part 3, but it is part 3. It's part 3 because my camera recording crashed in the middle of me trying to find the square root of 529. Turns out the square root of 529 is 23. So here we go, part 3 of the video, picking up right in the middle of this. That's frustrating and awkward, but here we are. So square root of 529 is 23, so this whole thing is 7 plus or minus 23 all over 12, which will give us our two answers. 7 plus 23 would be 30 over 12, which is 5 halves. 7 minus 23 would give us negative 16 over 12, which is negative 4 thirds. So we can just use the quadratic formula to get our answers pretty directly. If you feel like doing all of this crazy arithmetic is easier than factoring, then the crazy arithmetic route is available to you for your use freely. Again, I think most of the time factoring is going to be easier. I tend to think it's quicker, but if you don't like it, you have an alternative here. This works on anything that you can successfully set equal to 0. So, having found the answers this way, using the quadratic formula, which you should write down and put in your notes somewhere because it's pretty handy, I do want to finish the factoring technique so we can see what that looks like if we do the whole thing. The two numbers that multiply to 120 and add to negative 7 are negative 15 and 8. Negative 15 plus 8 is negative 7. Negative 15 times negative 8 is negative 120. So if we split our b term into these two pieces, you'll have 6x squared plus 8x minus 15x minus 20 equals 0. And then we can, now that there are 4 terms, we can split it right down the middle. We can probably pull a 2 out of this. Or we can pull a 2x out of that, get 3x plus 4, and we can pull a negative 5 out of this and get 3x plus 4 equals 0, and that will lead us to, we can pull out the 3x plus 4's, and we're left with 2x minus 5. So that's this thing factored and equaling 0, and hopefully you can tell that negative 4 thirds is what makes this piece equal 0, and 5 halves is what makes this piece equal 0. So we're getting the same answers either way. It's negative 4 thirds and 5 halves. This is a pretty extreme case. This is just a really challenging example that I made up as something that's challenging to factor, but something for which the quadratic equation is pretty readily available for use. But the precise point where you personally draw the line between things that you want to factor and things that you want to do arithmetic on, it's up to you. I want to do one more example because it's an example that you could use any of these techniques on. So one more equation, I'm going to do it 3 different ways. And we'll see how we feel about the different techniques. And hopefully my camera stops crashing so that I can have one nice video for this. 2x plus 5 squared plus 1 equals 10. This is my any technique you like works for this particular quadratic equation example. As I have mentioned before, I am extremely partial to the plan where you just set it equal to 0 and factor it. I like that plan a lot. So I'm going to start with that, and then we'll see how the other techniques compare. So I'm going to FOIL this bit. That'll give me 4x squared plus 20x Oh, is this a plus 5 or a minus 5 in there? Sorry, this should be minus 5. I copied it down wrong. So still twice the combined term should be 20x plus 25 plus 1 minus 10 equals 0. I'm already moving the 10 over. So I'll get 4x squared plus 20x. 26 minus 10 is minus 20x. Keep doing that. Plus 16 equals 0. To factor this, I'm just going to take the 4 out, and then I'll have x squared minus 5x plus 4 equals 0. So that can factor into x minus 1 and x minus 4 equals 0. So I should get x equals 1 and x equals 4. So again, this is the technique that I personally prefer. Set things equal to 0, factor. It'll probably work out nice. I'm going to do the quadratic formula from here, because this is the first time where the whole thing equals 0 and before I factored anything. So if I do the quadratic formula here, I will get x equals negative b is 20 plus or minus the square root of b squared is 400 minus 4ac. So a times c is 64. If you multiply that by 4, you should get 256. All over 2a should be 8. So 400 minus 256 is 144. So this is 20 plus or minus 12 over 8, which splits two ways. 20 plus 12 is 32 over 8, which is 4. Or 20 minus 12 is 8 over 8, which is 1. So 4 or 1 is exactly what we came up with over here. So the quadratic formula also works. If you feel like doing arithmetic on the scale of 400s and 256s, you can do this. That's fine. If we wanted to leave this alone and use the square root technique, we'd have to subtract 1 from each side. We would get 2x minus 5 squared equals 9. Taking the square root of that will give us 2x minus 5 equals 3, or 2x minus 5 equals negative 3. In either case, we would add 5 to both sides. So we get 2, this side would give us 2x equals 8, which turns into x equals 4. We got a match there. This side gives us 2x equals 2, which turns into x equals 1. Got our other match there. So there's one problem here, being done 3 different ways. We can use square roots, we can simplify and use the quadratic formula, we can simplify and factor. All of these options are available to you. Please use whatever you think is easiest for each problem you encounter. Use whatever makes the most sense. And good luck.